Good morning, everybody. This is Dr. S. Jyoti Assistant Professor, RMK College of Engineering and Technology. Today, our topic for discussion is nanochemistry. We are already knowing some basic knowledge about nanochemistry. It is not a new topic to us all. The chemistry deals with the nanoparticles. So we will be learning about some terminologies. What is nano exactly mean? So nano has been derived from the Greek word, which means very small, tiny, a billionth fraction of an unit. Yes. So we know that 1 nanometer is equal to 10 power minus 9 meter, or 1 billionth fraction of an unit. So nanoscience is nothing but it is a study of fundamental principles of molecules and structures with at least one dimension roughly between 1 to 100 nanometer. So this is our nano particle will range from. So we will know exactly what is this nanometer. So we will start with a meter, millimeter, microns, and we will learn about nanometer. So what is a meter? So 1 meter is equal to 3.28 feet. Or on the other hand, it is the distance from the tip of our nose to the end of your hand. So that is what is called as a meter. Millimeter is 1,000th of a meter, or 10 power minus 3 meter. Micron is a millionth of a meter, or 1,000th of a millimeter. That is 10 power minus 6 meter. Now coming to what is a nanometer. So nanometer is very small and it is 1,000th of a micron. So it is 10 power minus 9 meter, or a billionth of a meter. That is 1 billion nanometers in a meter. So we will see some examples of nanometer particle size. That is, if I take a water molecule, it will be 0.1 nanometer, gold particle 10 nanometer, virus 1 micrometer, hair 100 micrometer, then it will be a coin 1 centimeter. So nanomaterials will be ranging from 10 power minus 9 meter to 10 power minus 7 meter. Benzene, your carbon nanotubes, red blood cells 5 micrometer, and even a full stop that we use, it will be of 1 millimeter. Now, this also shows how small is a nanometer. So, nanometer is somewhere here, which shows us the distance from 1 meter to 1 nanometer. So it is a very long distance. So it comes from 10 centimeter, 1 centimeter, 1 millimeter. So various particles are ranging in different range, and our nanoparticle is very small. That is, it is in the range of 10 power minus 9 meter. So these are also the things that has been marked depending upon its sizes. We have rats, we have human hair, fly ash, RBCs, pollen grains. So all these are having here this above this 10 power minus 4 nanometer is the micro world, and below that is your nano world, 10 power minus 7 to here 10 power minus 9. It ranges, so it can be in the nanometer world, that is it is in the nano world. Now these are some of the applications of nanochemistry, 15 amazing applications of nanochemistry, where the nanochemistry is used in various applications, like starting from water treatment, textile industry, paints, energy, nano enzymes, nano medicinal applications. Then we have structural applications, defense and space applications, structure and engineering, automobile industry, cosmetic industry, catalysts, sensors, electronics, nanoelectronics, food and agriculture. So it doesn't stop with these 15 applications. There are so many of applications of nanochemistry in various fields. Depending upon the size dependent property, it has been used in various applications. So some other terminologies we should be knowing about is cluster, colloid, nanoparticle, and a nanocrystal. So, what is a cluster? It is a collection of many atoms or molecules. It can be ranging up to 50 units. So, 50 units can be minimum collected together, which forms a cluster. So, what are these colloids? It is a stable liquid phase containing particle in the range of 1 to 1000 nanometer. Obviously, the colloid will be in one such range, ranging from 1 to 1000 nanometer. Nanoparticle, it will be a particle which will be ranging from a size of 1 to 100 nanometer, and that could be non-crystalline, an aggregate of crystalline, or it can be a single crystalline. Nanocrystals, it is a solid particle that is a single crystal in the nanometer range. So this is the example of 0 dimension, 1 dimension, 2 dimension, and 3 dimensions. Fullerenes, nanoparticles comes under 0 dimension. Carbon nanotubes and carbon nanofibers comes under 1 dimension. Graphene nanofilms coatings comes under 2 dimension, and composite material comes under 3 dimensional particles of nano material. So we have seen that we have understood that carbon is the basic element of life, and it is having the ability to bond with different elements in different ways, and it is the sixth most abundant element in the universe, and that is mostly known for many carbon materials that has been formed. For example, if we take diamond, if we take graphite, fullerene, then we take carbon nanotubes, the carbon nanoparticles, it is mainly made up of carbon. And these are the different solid forms of carbon. We know that graphite, which is hexagonal, nanotubes, diamond, carbon 60 fullerene, and lonsdaleite is all these things are made up of carbon.